Hi Evergreen, let's do our midterm review 2. This time we're going to cover chapters 3 and 4. Let's get started. Make sure you have it printed, the worksheet that goes with this PowerPoint or this video, and we can work these problems together. So the first one says 7 times 6 plus x plus 8. So we need to distribute the 7. 7 times 6 plus 7 times x. And then we need to combine our like terms, 42 and 8, which makes 50. 50 plus 7x. That's the farthest we can simplify this expression. Next, we have 1/3 times 12x minus 15y. Now, I know some of you are going to be looking at this and go, oh my goodness, I don't know how to multiply it. A fraction. It's okay. Don't be worried. This is the same as saying 12 divided by 3 and 15 divided by 3. Since there's only a 1 in the numerator, that is what this is equivalent to. So we're going to say 12x divided by 3 is 4x, and 15y divided by 3 is 5y. And this is the farthest that you can simplify. Great job. Okay, we have a little division, so we are just going to do one term at a time. So first we're going to do negative 30 divided by negative 5, which is 6. Then we're going to do negative 65 divided by negative 5, which gives us a positive 13r. And then 100s, and it's positive, divided by negative 5, which is a total of negative 20s. Super job. Let's keep going. Okay, so when you see these parentheses, it means distribute. So let's do 5 times 3x and 5 times 4. Then we'll rewrite the rest of our expression. Now we need to combine our like terms. And when we combine our like terms, I want you to notice that we have 15 and a negative 15. And we have 20 and a negative 20. So these both cancel out. And so our answer is 0. Isn't that interesting? Okay, here we have a lot of distributing to do, but it's no big deal. Just a little bitty multiplication, so just take it one step at a time and be really careful so you don't make a mistake that's silly that makes your whole problem wrong. Ready? So 5 times 2x is 10x. 5 times negative 3y, negative 15y. 5 times 7, 35. Now let's work on the right side. Negative 4 times 3 is negative 12y. Negative 4 times 5x is negative 20x. Negative 4 times negative 1 is 4. And now we have the easy job of just combining our like terms. So let's look closely. I went ahead and highlighted them to help our eyes focus, but let's start with the x's since 10x is first. We have 10x and a negative 20x, which will give us negative 10x. And then we look at our y's. We have negative 15y and negative 12y, which gives us negative 27y. Then 35 plus 4, which gives us 39. This is the simplified expression. So when you see something big like this, don't grow weary. One step at a time, you can do it. Okay, let's see if you remember some vocabulary. Circle the correct axiom that describes this expression. So we have x plus y equals y plus x. Are these the same terms on both sides? Yes. Is the same thing happening on both sides? Yes. Is it in the same order? X plus y, y plus x? No. Are there any parentheses used or any groups used? No. So therefore, you should know that this is commutative. And this helps me, little, picture helps me remember what commutative is. It's like a community. People are always in different groups. People aren't always walking around in the same groups. They're always mixing and mingling and always in different environments. So this is commutative. Each side is like a little community. The same people are in there, but they're in different spots all the time. Now, I don't know if that helps you, but that's how I remembered it when I was a kid. So this is commutative. Next, circle the correct axiom that describes this expression. So we have x plus y plus z, x plus y plus z. Now, On both sides of this equal sign, we have the same terms. We have the same order. The only difference is that I see parentheses. When you see parentheses, it should be like associative, okay? Because there are groups happening. That's what associative means. It's like, I'm associating with you right now, and later I'm going to associate with you. Do you see what term is in both parenthesis sets? Y. So when I was a kid, here's one other silly story. I used to think of it as little friends. So Y is friends with X. They're kind of leaving Z out. Oh, that's so rude. Oh, but then over on the next day, Y is playing out with Z and leaving X out. So I just think of groups and different sets happening first or second, but the same terms. Associative. Okay, back to simple. We're going to combine our like terms. So we have 5x minus 7x, which equals negative 2x. Then we're going to copy the rest of our problem down. Now we need to subtract 21 from both sides. Rewrite our expression. We have negative 2x equals 6. Right now, that x has a times negative 2, so we are going to divide by negative 2 on both sides. And x gives us negative 3. Could you check this in your calculator? Yes, you could. You could say 5 times negative 3 minus 7 times negative 3 plus 21, and it should equal 27. On your test, if you have extra time at the end, you should be checking your work. It will help you ensure that you are correct. Okay, let's distribute. We have two little distributing. We have 3 times a and plus 3 times 2. And then we have negative 1. Remember, it's a little invisible 1 there. Negative 1 times a, negative 1 times negative 1 equals 17. Now let's combine our like terms. We have 3a and negative a, which gives us 2a. I'm sorry. Oops, I wrote 2x. 2a should be there. And then 6 plus 1 is 7. Now equals 17. Let's get rid of this 7. Subtract 7 on both sides. 2x equals 10. Divide by 2 on both sides. X equals 5. Could you check this in your calculator? Yes, you could. Okay, decimals. I would definitely use your calculator for this one so you don't end up making a little bitty mistake. So we are going to say 2.4 times 3.1, x. 2.4 times 4.9. We're going to write that down. And now we need to combine our like terms. Let's start with our x's, with the variables. So we're going to subtract 0.87x on both sides, and we get 6.57x plus 11.76 equals 75.9. Let's subtract this 11 and 76/100ths on both sides, and we get 6.57x equals 64.14. And then when you divide 64.14 by 6 and 57/100ths, your answer is approximately, because we had to round on this one, so we're going to use our wiggly approximate equal sign. It's 9 and 76/100ths. You're doing so good. Keep it up. Okay, another little decimal problem. 7 times 2.3 times 7 times, subtracting, 7 times 0.4, and that's a negative 0.4. Sorry, I got a little tongue-tied there. So we have our expression. Now we need to combine our like terms. Let's start with these variables. I always like to start with the variables. Oops, that should be a minus x. This is a little mistake here. You see how this is a positive x? So if I wanted to get rid of it, I should say minus x, and this would be a negative 3.8. So I'm not going to keep going on this one because this has a mistake in it. I want you to solve this one by yourself. Oopsie whoopsies. Okay, here's a little problem. Dr. Hoffman has been peeling carrots at the rate of 3 carrots per minute. 4 minutes later, Mrs. Baird joins him and peels at the rate of 5 carrots per minute. Let x equal the number of minutes Dr. Hoffman has been peeling. Okay, so Dr. Hoffman, 3 carrots per minute. So that is 3x, right? And then Mrs. Baird is doing 5 carats per minute. So that's 5x, but she was 4 minutes late, right? So this is what our expression would be if we were trying to find the total number of carrots they both working together were going to peel. So we have Dr. Hoffman, 3x, and we have Mrs. Baird, x minus 4, because she was 4 minutes late, times 5, because this is her rate. Okay, this one's about my cat. Okay, so Gertrude the cat weighs 26 pounds. She's on a diet where she will lose 0.4 pounds each week. Write an expression for her weight loss plan. So first we have to start with how much she weighs. She weighs 26 pounds. And now are we losing or gaining weight? Losing. So when you're losing, you are subtracting. And then we have 4/10 per week. And remember, an x equals week. So therefore, our expression is 26 minus 0.4x. Okay, I think this is our last problem. Let's look. Let's distribute this 11 times x and 11 times 3. And then at the same time, let's work on the left side of our equal sign and combine 6x and 5x. Let's write that down. So we have 11x plus 33, and on the right we had 11 times x and 11 times 3, which gives us 11x plus 33. Do you see it's exactly the same? Yes! So this is the identity property, and any number we plug in for x could make this true. If we put 1 in for x on both sides, it would always equal each other. 2, 3, or even a decimal, it would always work because it's exactly the same on both sides. And so therefore, any real number can be a solution to this equation. Oh, we have more. Oopsies. Okay, CX equals 92. And it says solve it if we know that x equals 4. So we're going to rewrite this and replace x with 4. C4 equals 92. Now we want to see what c equals. So we're going to divide by 4 on both sides. And c will equal 23. You could check this. You could say 23 times 4. Does it equal 92? Yes. Or you could do a little fact family and say, 92 divided by 23, does that equal 4? Okay, let's distribute again. We have 3 distributings to do. So we have 3 times 3x and 3 times 1. Then we'll move over and we'll say -1 times x, -1 times -1. And then on the right, 6 times x, 6 times 10. We have all that written down. Now we're going to combine our like terms on the left. We have 9x and -x, which gives us 8x. And we have 3x plus 1, which gives us 4. 6x plus 60. Let's combine our like terms. Let's move those variable sides over. So we have -x minus -6x. We get 2x plus 4 equals 60. Let's subtract 4 from both sides, and we get 2x equals 56. Then divide by 2 on both sides. Oops, I skipped a little step on my work, but we should divide by 2 on both sides, and x equals 28. You are a smarty pants! You're doing so good, and I can't wait to see how well you do on your midterm. If you have any questions, send me an email or talk to me in class before our test. Bye!